So we're going to look at section 5.3. We'll spend 3 days on it. If there's school every day this week, we'll have a review day. If not, we probably won't have the review day. Okay, so let me scroll down. And we're going to look at solving systems of equations using our third method, which is elimination. So on the blank on your guided notes, okay, under the first bullet, it says, today we will solve systems of equations using, and then it says elimination. And it's pretty much exactly what it sounds like. Elimination is where you're trying to eliminate one of the letters. Which letter? Well, it depends on the problem. Sometimes you can do these problems more than one way. But this is the goal. Okay, so on the second bullet where it says what the goal of solving systems by elimination is to add two equations together and hope that we can cancel one of the variables out. Because that's the whole thing that makes solving a system hard. You have two variables. Well, if we can make one of them disappear, then we'll only have one variable. And that's easier. So let me write something down. You guys don't have to put what I'm going to do next. But I'm going to show you two equations you can add together, and one of the variables would cancel out. So this is kind of going to be the goal of what you want to get. So let's say we had something like 3y plus 2x equals 4, and 2y, let's go like this, 5y minus 2x equals 3. This is a problem that would not work well for substitution. Okay, we're not going to actually solve this because I don't think the answer is going to come out nice. So I just want you to watch this. The reason substitution wouldn't be good is because, remember, with substitution, you're looking for a letter that's by itself with no number next to it. Do we have any letters in this problem that don't have numbers next to them? Yeah. No. So it's going to make substitution really, really messy. But think of these as columns. And then just add up what's in the columns. So I have my y's, my x's, and then my numbers. What's 3y plus 5y? Yeah? Yep, 8y. What's 2x plus negative 2x? If you add that second column. Yeah? 0. That's called elimination. Because these added together to make 0. They're gone. And then what's 4 plus 3? Yeah? 7. So now you're down to an equation where all you have to do is get y by itself by dividing both sides by 8. You're done. That's how you get y. Right, so that's the idea with elimination. You always want something like that to happen. If it's not set up for that to happen, we need to make that happen somehow. Okay, but that's elimination. So you might notice like these equations were set up a certain way. The y's were lined up first, the x's were lined up second, and the numbers were lined up third on the right. That's how you have to do elimination. You have to have those things lined up. So the next bullet says, before we can eliminate or cancel out the equations, we want them to be set up in this format. That's the format that you want. You're basically going to have your x first, and then you're going to have either a plus or a minus. Could be either way. Then you're going to have your y, then an equal sign, and then a number. Here's an example of what you want. Number with x, then something with a y, an equal sign, and then a number by itself. So let's go back to that one that I set up that we didn't really solve. And let me show you what you look for to see if elimination is going to work. You're going to look for three things. So you guys have that sentence on your guided notes, but you don't have the three things written in there yet. Okay. So let me show you the three things. Look at just what's right there. There's three things we're going to look for. Same letter, X and X. Same number, 2 and 2. Opposite signs, plus, minus. Those are the three things you look for. Same letter, same number, different signs. Let me put that down so you guys can copy it. So you look for the same letter, same number, either way you want to write it, and then different signs. One's a plus, one's a minus. If they give you a problem and that's how it's set up, then elimination is going to work perfect. If they don't give you this situation, then we need to fix it so we have that situation. This next sentence you guys don't have on your guided notes, I don't think. It just says what we're doing this week. We're going to look at 5 different kind of setups you can have for elimination. We're going to start with the easiest setup, and then we'll get to the harder setups. This type of problem that I just showed you here, that's the easiest setup. It automatically has everything already perfect for elimination. So what I'm going to do is I'm just going to give you guys one method, or I think on your guided notes, does it say situation in that column? All right, so it's a little different, but that's the same idea. And for some reason, I don't think I put the example column. So you could, there's not much space, but you could put the example off to the side if you wanted. Either on the left or the right. But situation 1, what are you going to look for? Same letter, same number, different sign. I know it's kind of small, but that's what it says. Same letter, same number, different sign. Here's an example of a problem that's what we're going to call situation number 1. You don't have to tell me, but if you look at it, you should be able to see 2 things there, right above and below each other, that have the same letter, same number, and then opposite signs. Either the X column or the Y column, one of those 2. If that's the situation you have, all we're going to do is add the columns vertically. So we're going to add the columns that you have vertically. And I think you guys have most of that filled in on your guided notes. Now, you don't have these spots yet because we haven't got to them yet. But there's going to be 4 more situations that we're going to look at throughout the week. And if we finish situation 1 and we really have a lot of time left, we might start to look at situation 2. But we'll see. I don't know what we'll have time for. Just trying to adjust for tomorrow. All right, let's try it again. So this is going to be our first time going through this kind of template, and I'll show you guys kind of how we do it. All right, so here's the problem that we're going to solve. Example 1a says x plus y equals 4, and negative x plus y equals negative 2. Now, we're going to go through each one of these steps one at a time. But the first step says add the equations to eliminate. In order to add them, we have to make sure the x's are lined up, the y's are lined up, and the numbers are lined up. So looking at example 1a, and again, you don't have to copy all that yet. Does it look like the x's are lined up, the y's are lined up, and then the numbers are lined up? Like, yeah. Yeah. What's an example of something not lined up? Let me show you. That's not lined up. They each have x's and y's and then a constant, but the x's are not in the same column, the y's are not in the same column, and then the numbers are not in the same column. So we'd have to fix this one so that everything is lined up first. But in this one, they're already lined up. So what we're going to do is copy these two equations onto these two lines that say equation 1 and 2. X plus y equals 4. And negative x plus y equals negative 2. And now, in the first box, we're going to add these up. That's what that dotted line up and down means. We're going to add everything up vertically. So let's start with the first column. What's x plus negative x? Yeah, nothing. That cancels out. So that's gone. All right, let's do the next one. Positive y plus y. Yeah, 2y. And then 4 plus negative 2. Yeah? 2. Okay, so that's all you have to do in the first box. Okay, now, sometimes we don't really have enough space here, so that's what the second box is for. The second box gives us a little bit more room to solve this equation. I think this one you'd probably have enough room to do it, but let's copy it over so we've got some more space. So all I'm doing now is I'm going to solve for the variable that's left. In this case, the variable that remains is y. Sometimes it might be x, but in this case it's y. Okay. And how would I get y by itself in that equation? Yep.
By 2.
Yep. Divide each side by 2. 2's cancel. And then in this box with the circles, that's where you're going to put your answer. Y equals. And what's going to go in that circle on the right? Yeah? 1. There you go. Now, remember, we're solving a system. How many letters do you have to figure out when you're solving a system? Yeah? 2. You've got 1. Okay, so we have y equals 1. Now, we're going to take the variable that we just figured out, which is y, and we're going to plug that variable back into one of the original problems and solve. It does not matter which one you use. But you're going to take the 1 and you're going to fill it back in for y in either one of those equations. Now, does anybody see one that they think is easier to plug y back into? Yeah? Yeah, I would say the top one because there's no negatives in it. All right, if you can deal with an equation that's all positive numbers, that's probably easier than having a negative. Okay. So we're going to take this one and we're going to throw it into the top equation. So we're going to have x plus, and Dorian, what am I going to fill in for 1? Well, I mean, sorry, what am I going to fill in for y right there? Yeah, we're going to fill in 1. So that's the top equation. X plus 1 equals 4. And now the last part, it says solve. So how do I get the x by itself in that one? Yeah, 8. Subtract 1 from both sides. Perfect. That's gone. And can you tell me, Aiden, what does that give me? X equals 3. That's it. That's how you write your answer. So the boxes just kind of tell you what to do. Add up your equations vertically. Solve for the variable that's left after you eliminated one of them. And then you have to go back and find the other variable. That's the idea of substitution. Elimination. Any question on that? So this case is pretty easy, which is why I think we may get to case 2 today. If I thought for sure we'd have school tomorrow, then I wouldn't worry about getting to case 2. But if we get to case 2, we might still have time for a review day then. I don't know. We'll see. But I don't want to go too fast. So if it seems too fast, just let me know and say it's too fast. Any questions on that? All right. Let's try this one. So example 1b. So this is on the back of the guided notes. Let me just see something. Okay, so it's x minus 2y equals 2. And 2x plus 2y equals 1. Yeah, I'm not going to put those little reminders on each box like I did the first time. So we'll go back and look at them. Yeah. So remember, the reminder on the first box said, are the equations lined up? X's, Y's, and then numbers. If they're not, let's fix it before we write them down here. So Maya, what do you think? Are the equations lined up this time?
Yes.
Yeah. So the equations have the x's first, the y's second, and the numbers third. So copy those down. 2x plus 2y equals 1. And now, add the equations vertically. So Joe, what do I get when I add the x column?
2.
Okay, what's the value of the x in equation 1?
1.
1x, yep. And what's the value of x in equation 2? 2. And what do you get if you add those together? 3x, yep. So 3x. Abby, how about if I add my y column on?
Does it cancel it?
It cancels out, right? Same letter, same number, different signs. Whenever you have same letter, same number, different signs, they cancel out. Equals. And what's going to go on the right side of the equal sign? Chop. 3. Add up that column. 2 plus 1 gives me 3. Now, box 2. Solve for the variable. So if you need some more space, just copy it over. Now you got a brand new box. You can do all your work in. Emily, how do I get x by itself there? Perfect. And can you tell me, what does that give me for x? 1. So notice this time we got x first. Last time we got y first. It doesn't matter. Okay, that doesn't make a difference. It all depends on what letter eliminates. Whatever letter eliminates, you're solving for the other one first. Okay, so we've got that. And now box 3. Plug in what we just got into the original equation. And now we'll solve for the last letter. All right. Lexi, what letter did I just solve for? X. What did I get? 1. Now, where do you want to fill that 1 back in? The top equation or the bottom? Top. So we're going to take a 1 and we're going to fill it in for x. So we're going to have 1 minus 2y equals 2. All right, and now we have to solve for y. So we want to get everything that's not a y on the right side. Tirza, can you tell me the first thing that I could move to the other side, and then how I would move it?
The 1.
Yep, we're going to move this 1 over with the 2. And how do you put that 1 on the other side?
Subtract 1 on the side.
Perfect. So subtract 1. 1 minus 1 is gone. And we get negative 2y equals 2 minus 1 is 1. And Finn, what's my last step to get y by itself?
Divide by -2.
Perfect. So we're going to divide by -2. These cancel out. And can you tell me what I get for y?
Y equals -2.
So what does it say up on the board we get? Y equals
1 divided by -2.
1 divided by -2, that's -1/2. Whether you put the negative in the top or the bottom of a fraction, that does not matter. I usually put the negative in the top. So I would probably write the answer like this. -1/2. But if you leave it in the bottom, you're not wrong. That's fine. So y equals -1/2. And if you changed it to a decimal, you could, like -0.5. That's -1/2. Just like when we do slope, we normally leave it as a fraction. It's the same idea. We leave it as a fraction. Okay, any questions on that one? All right, so why don't you guys give that one a try? Take a couple minutes on your own, see if you can solve it, and then we'll go through it together. Okay, so remember, first question you always want to ask is everything lined up? If it is, go ahead and copy the equations down. So can somebody answer that for me first? Are the x's in a column, the y's, and then the numbers? Yep?
Yes.
Yes, they are. We are going to do a problem where they're not. Okay, and we're going to fix that, and that's what we'll do next. Okay, but these are lined up. So -2x plus 3y equals 2, and 2x plus 7y equals 18. Now, we're going to add these up vertically, and the hope is that we already have same letter, same number, different sum. If we do, that column is going to disappear. So let's go through it and see. Okay. First column. What do you get when you add those up? Yeah? They cancel out because they have the same letter, the same number, and then different signs. So those are gone, which means we have eliminated the x's. That's why this is called elimination. Okay, now add the second column. 3y and 7y. What do we get? 10y equals, and then don't forget to add your third column, The 2 and the 18, 20. Okay, so 10y equals 20. Copy that down so you've got some more space in case you need it. A lot of these problems you don't really need more space. All right, so 10y equals 20. Now solve for y. How are we going to get y by itself there? Yep.
Divide 10 by both sides.
Okay, so divide by 10 on both sides. So the 10 is gone. And what's 20 divided by 10? 2. There's your first answer. Y equals 2. Now, we're going to take that number, and what do we do with the 2? Yeah? Plug it back in for y. Does it matter which equation we use? No, either one. So let's, I don't know, you can pick. Which one do you want to do, top or bottom? Bottom. Okay. So let's plug in 2 for y. So 2x plus, and now fill in a 2 for y. So it's going to be 7 times 2. Yep.
Can I go to that?
Yeah. Did you have a question?
No, I thought you were asking about 7 times 2.
Oh, sure. What is it?
14.
14. So 2x plus 14 equals 18. Usually there's a few more steps to solve this one than there was the first one. So that's our first step. What's my second step? To get the x by itself. Yep. Good. Subtract 14 from both sides. And how about Annika, if I subtract 14 from both sides, what does that give me on the left?
You bring down the 2x.
Just bring down the 2x. And then how about on the right?
That's 4.
4. Good. So we get 2x equals 4. And Cadence, what's my last step?
Divide 2 by both sides.
Divide both sides by 2. So now we get x equals, what's 4 divided by 2? 2. And so we got the same answer for x and y. So that doesn't always have to happen, but in this case it did. Okay. Any question on that? All right, so up till now, everything has always been lined up. If we get a problem where that first step of lining things up isn't already done for us, then we have to do that part first. Once we do that, it's just like the other problems. Okay, so let's try an example where we actually have to line them up first. Okay, so let's look at this one. So we've got 2x equals 3y minus 5, and 3y equals 4x plus 1. Are these lined up the way we want? No, remember how we want them. We want them lined up just like this. The x first, then a plus or a minus, then a y, then an equals, then a number. That's the order we want. Okay, are either one of these equations in that pattern? The x first, then the y right next to it, then an equal sign, and then a number. Yeah? No, neither one of them is the way we want it. So let's start with this top. I think if we move one thing in that equation, we can make that one look like what we want. Does anybody know what we have to move to make this equation look like the other ones we've done? Yeah. We have to move the 3y. Because remember, you want x, then a plus or a minus, then the y, then the number. Okay, how would you move that 3y, Abby? Yep. Subtract 3y from both sides. And can you tell me what that would give you? when you do that?
Negative 3y.
Okay, we're gonna put that second because we want to put the y second.
2x
So yeah, 2x minus 3y equals negative 5. So in that step, we didn't solve anything. All we did was reorder things because we got to get them in the right order. Now that equation is ready to write down in box 1. 2x minus 3y equals negative 5. Okay. Let's look at equation 2. Is equation 2 in the order we want? What do you think? Yeah. No. We have to move something there to make it look more like this pattern. Yeah. We got to move what? Okay, so we want to rewrite it by moving, which thing do you want to move there? We just have to move one thing. Well, we want the things without letters on the right, so we want to keep the 1 where it is, because that's the thing without a letter. Anyone else? Yep. Well, do we want the y on the left side? Let's go back and look at our pattern we have right here. Where's the y in that equation? Is it on the left side or is it on the right side? Dorian? Is it on the left or the right?
It's on the left.
It's on the left. So we want the y on the left. Right? This is the left. That's the right. That's the left. So left, right. We want the y on the left. We want the x's and y's on the left. We want numbers on the right that don't have letters. So what's the only thing here that doesn't fit that pattern I just said? Yeah?
4x.
Right, where do we want x's and y's?
On the left side.
We want them on the left, and in that case, the 4x is on the right. So we don't want the 4x there. So how am I going to put 4x on the left? Yeah, subtract it. So minus 4x, minus 4x. And can you tell me, what do you get, Lexi, on the left side when you write this out? Yes, and I like the way she wrote it. You want to put it in alphabetical order. The x first, and the number with x is a negative 4, and then the y second, because y comes after x alphabetically. And the number with the y is the 3. So negative 4x plus 3y. And what's on the other side? Yep, 1. Now that equation is ready to be copied down in box 2 because it's all lined up. Negative 4x plus 3y equals 1. And hopefully once we line everything up, you guys see same letter, same number, opposite sign. If you don't, we haven't talked about how to do it yet. So does anybody see which column there has the same letter, same number, opposite signs? Yeah, just in there. The y column. So when we add those up, they should come out to 0. Let's try it and see. Okay, first column. Anaya, what do I get when I add up that first column?
It cancels out.
The x column.
Oh.
Negative 2.
-2 x. Yeah. Okay, so there's the first column. Caleb, what about the second column?
Second column. Can you repeat the question?
when we add up the second column.
I don't know.
Yeah.
I don't really understand what you're saying.
So we're adding up the numbers in the second column. Do you know what I mean by second column?
Oh. Okay, that'd be negative. Would that be -2?
All right, what did you add to get that?
Add 2x plus -4x.
So that's the first column.
Wait,
So
that one's already done.
that one's done.
Oh. That would be 0 to cancel out. Right?
0. So negative 3y plus 3y, that's gone. And Brady, what about the third column?
-4.
Yep, -4. Okay, and Mia, what do I do with this negative 2x equals -4 now? Yeah, we're just going to copy it over to the second box so we have some more space to write our answer. All right. And how about Tirza, how am I going to solve that for x?
Well, you're gonna divide both sides by -2x.
Yep. Divide, can you say it again? Divide by what?
-2.
Yep, just -2. Okay, so that's going to cancel the negative and the number out from the left. And we're going to get x equals, what's -4 divided by -2? Yeah, 2. Because it's a negative divided by a negative, so you can cross that out. And you get just 2. Perfect. Okay. Any questions on that one? So now we've got the x. What do I do with the 2 now? Because I still have to find something else. Yeah. Plug it in for x. Now I'm going to move this just so I can see it a little better. You can pick either one of the equations in these boxes. Alyssa, which one do you want to plug back into? The top one or the bottom one? Top one? Okay, so we're gonna take the 2 and we're gonna fill that back in for x and see what we get. Okay, so we're gonna have 2 times 2 minus 3y equals -5. All right. How about Sean? What's the first thing I should do there? Yep. Let's do these parentheses. And what do you get? 4. So 4 minus 3y equals -5. Okay, good. What would I do next? Yeah.
Subtract 4.
Perfect. So subtract your 4 from both sides. And that gives me -3y equals
-9.
-9. Good. And my last step. Yeah. Perfect. Divide by -3. -3. So everything's gone on the left. We got y by itself. And what's -9 divided by -3? Just be careful because it's a negative divided by a negative. Yep, +3. Okay, so you might notice every problem we've done so far has come out to relatively nice answers. It is possible you get fractions and decimals, but I'll tell you most of the problems that I give you are not going to come out messy. They're going to come out to nice answers. Yeah. Yeah. Okay. Does anyone have any questions on that? try. Did I have one more on your guided notes for that type? No, that was 2A. Oh, we didn't have an example 1C, did we? Did we skip 1C? No, we did that. So we did 1C, we did 1A, we did 1B, 2A. Let's see, maybe I don't have a 2B. Yeah, I didn't do a 2B. That's okay. Any question on that type? Okay, so I think what we'll do is, I don't want to do the whole next thing because we still have about a little over 20 minutes, 25 minutes. We'll look at situation 2. All right, so we'll do that situation, and then we'll stop there. Okay, unless does anybody want to see one more of this type? We may have to do this in situation 2 as well. So this might come up again anyway. Anyone want to see one more of that type? Okay. So when we look at situation number 2, we're still going to pretty much use the same template, but you're going to notice there's one extra thing on it. And I'll show you what that box is for. So I'm not going to say yesterday because we just did this a few minutes ago, but remember how you always want your equations lined up. The x, then the plus or the minus, then the y, and then the number by itself on the right. So in situation 1, remember what you're looking for. Same number, same letter, different sign. Notice I put no multiplication here. You'll know what that means in a minute. Okay. Now remember situation 1, you guys already filled this box out. So we're not going to fill that out again. You can just look at your notes. But this is the first thing you have to write down on today's guided notes. We're actually just going to do situation 2 today. And we might finish part of situation 2 next time. We're definitely not going to do situation 3. So the 2 things you have to write down is after the word different because we have to, and you're going to put the word multiply on the first blank. And then it says, but still make sure that the equations are lined up. That means the x plus or minus y, and then the number. So hang on to this guided notes because I'm going to have you guys keep these and we'll use them next time. I didn't make enough copies to give everybody 2 of them, so don't lose your guided notes. Okay, so this is just something to look at. What do you guys notice is different between the top template, which is the one that we did first, and this bottom one? There's something extra there that wasn't in the top. Does anybody see what it is? Yeah? Yeah, there's 2 boxes, and then we're going to put a number in those boxes. And I'll show you how that works. But that's exactly the difference. There's 2 boxes. That's the only difference. Everything else is exactly the same. So here is what we're looking for in situation 2. And then I'll show you guys an example. Situation 2 doesn't have same letter, same number, different signs. That's what we want it to have. But it doesn't have that starting out. What it's going to have starting out is a single positive variable in both equations. Well, the problem is you don't want both equations to have a positive. You want one positive and you want one negative. So if something's positive, how do you make it negative? You multiply it by -1. That's the only extra step for situation 2. Multiply everything in 1. Which one? Doesn't matter. You pick. But multiply everything in one of the equations by -1. Let's try an example. So here's my 2 equations. -x plus y equals -3, and 4x plus y equals 2. Very first thing I ask myself, are they lined up? Do we have the x's and y's on the left and the numbers on the right? What do you think? Yep, everything is lined up. If they were not lined up, you'd have to fix that first. And that's what we did in the last problem. But everything here is lined up. Once everything is lined up, you can copy them down into the equation 1 and 2 lines. Same step. Now, let's go through our different situations and think which one we have to use. Let's start with situation 1. That's the easiest. Do we have same letter, same number, opposite signs in these 2 equations? Do we have that? Look for the same letter, the same number, and then the signs have to be opposites. Anybody think we have that? Yes or no? Abby? Okay, which column do you think has the same letter, same number, and opposite signs? Which one? The Y column? Okay, so read to me what's in the Y column. What's the top Y say? Or what's the Y in the top equation say? Just Y. What's the Y in the bottom equation? So those are the same letter. What number is in front of them both? Yeah, you could pretend like there's a 1 there. So same letter, same number. Do they have opposite signs? No. And if you look at the X column, we have the same letter, but here we don't even have the same number. So we don't have situation 1 here. We do not have same letter, same number, opposite signs. So let's move to situation 2 and see if it's this one. Do we have a single positive variable in both equations? What do you think? Natalie, do we have a single positive variable in both equations? Which variable is positive and single? Like there's no number in front of it in both. Yeah. If you look at these 2 equations, the Y is a single positive variable by itself in both. So what does it say that we need to do when we have this kind of situation? What do the directions say to do? Yeah? Multiply everything in one of the equations by -1. And that's what those boxes are for. So we can pick. Let's multiply everything. Let's do the top. Let's multiply everything in the top equation by -1. So when you put the -1 in that box, what you're really doing with it is this. You're multiplying everything in the top equation by -1. And remember, the goal is to end up with same letter, same number, opposite signs. Let's see if multiplying everything by -1 does that. Emily, what's -1 times x? Sorry, -1 times -1 times -x. X. Then what's -1 times y? -1y equals, and then -1 times -3. Yep, 3. Now, this bottom one, I'm not going to put anything in that box. I'm not going to use it. The bottom equation just gets copied down exactly the way it is. So we have 4x plus y equals 2. Now, look what happened. If we added these columns up the way they were first, nothing would have eliminated. Negative x and 4 would have given me 3x. Positive y and positive y would have given me 2y. Nothing would have disappeared. What happens if we add these columns now? All we did was multiply everything in the top equation by -1. But what happens if we add the columns up? Yeah?
One of the variables will not be there.
Right, one of the variables won't be there anymore. That was the goal, to make it so one of the variables is no longer there. Can you tell me which one is going to disappear? The y. Let's add them up and see what happens. Micah, what do I get if I add up my first column? 5x. And Anaya, my second column? That cancels out. Which would not have happened before we multiplied by -1. That's why we had to do that. And my third column. Lexi? 5. This is exactly the same from here. There's nothing different about this. Okay. So we get 5x equals 5. And what do I do on both sides to get x alone? Sean? Yeah. Divide by 5. And what does that give me for x? 1. Perfect. Okay. Now, Dorian, what do I do with this 1?
You plug it into one of the equations.
Yeah, plug it back into one of the equations. I don't know, I would say maybe the top one to me looks a little easier because the numbers are smaller. So when we plug it back into the top, we're going to have -1 plus y equals -3. And really there's only one step, and then you're done. How do I get y by itself in that last box? Yeah.
Add one to both sides.
Add 1 to both sides. And what does that give me for y, Dorian? What's -3 plus 1?
-2.
-2. So the only extra step was multiplying by -1. And the way you know to do that is if you see same letter with the same sign. We don't want same letter, same sign. We need same letter, opposite sign. And multiplying by -1 fixes that. Okay, so that's an example of situation 2. So what we'll do next time is we'll do one more of that type, and then we'll also do situation 3. Okay, let me put up the